You know, neural networks are incredibly powerful, right? But what happens when the data you're looking at isn't just a static picture? What about data that actually unfolds over time? You know, like a sentence, a piece of music, or even a stock chart. Well, today, we're diving into the networks that were built for exactly that, recurrent neural networks, or as you'll hear them called, RNNs. So, let's start with a little puzzle. A standard neural network is amazing at, say, spotting a cat in a photo. But why would that same super smart network kind of choke on a simple sentence? Well, it's because the order of the words changes everything. The dog chased the cat means something completely different from the cat chased the dog, and your standard networks, they often miss that crucial sequential context. And that brings us right to the heart of the matter. See, on the left, you've got your standard feed-forward network. Information just flows straight through one way. But on the right, that's our recurrent neural network. And you see that loop right in the middle? That little loop? That is the entire game changer. It's how an RNN literally creates a memory.
This really breaks down that core difference for us. A feed-forward network treats every single input like it's the first thing it's ever seen. It has absolutely no memory of the past. An RNN, though, with that feedback loop, is built specifically so it can remember. It's designed from the ground up for data where what came before is essential to understanding what's happening right now.
Okay, so that ability to remember, that's the first huge advantage we really need to unpack. It's like having a built-in memory that lets an RNN actually understand context and order.
So this diagram here basically unfolds that memory loop so we can see how it works over time. Information from one step gets passed along and actually influences the next step, creating this sort of chain of memory. And what's really efficient about this is that the network uses the exact same set of rules, or weights, at every single step. That's a concept called parameter sharing. It just learns one set of rules and then applies it over and over again to the whole sequence.
All right, so this memory mechanism we've been talking about, what's the technical term for it? It's called the hidden state. This is the part of the network that the information actually loops back into. You can think of it as the RNN's working memory, or its scratch pad, that's constantly being updated with a summary of everything it's seen so far.
Now, having this memory gives RNNs another massive advantage. I mean, think about it. Real-world data is messy, it's not all the same size. A sentence can be 3 words or it can be 30. A song can be a minute long or 10 minutes long. RNNs are built to handle this kind of variable length data beautifully.
And honestly, this is a complete game changer. See, most networks need a fixed-sized input. That means you have to do all this awkward stuff like chop up your data or add a bunch of filler to make it fit. But an RNN, it just processes a sequence one element at a time for as long as it needs to. And that flexibility means the exact same model could understand a single word, or it could process an entire book.
This chart just lays out the practical difference perfectly. FNNs are fantastic for static snapshots, like classifying a single image. But for data that tells a story, like figuring out the sentiment of a movie review, translating a sentence, or recognizing speech, well, RNNs are absolutely the right tool for that job. So here's the bottom line. By remembering the past and being able to handle sequences of pretty much any length, RNNs unlock a whole new world of insights from data where the order of things is everything. They're the key to understanding data that has a timeline, where context is absolutely crucial. And that really leaves us with a pretty powerful question to think about. If a network can remember the beginning of a sentence by the time it gets to the end, it's not just processing words anymore, it's actually starting to understand context. So what happens when that ability to grasp the bigger story extends beyond just sentences, to things like financial markets or climate patterns, or maybe even human behavior?